Hi, in this video we're going to continue learning about the metric system. Here we're going to convert from one metric unit to another. Remember, the metric system has units with a base unit, either meters, liters, or grams, and some sort of prefix to indicate units that are much bigger or much smaller than the base units. Here's some style points. Remember, when you're writing, metric symbols never end with a period unless they're the last word in the sentence. They're not an abbreviation like Mr. or Mrs. Also, metric symbols should be preceded by the digits with a space between the digit and the symbol. It's not correct to have the symbol immediately following the digit when you're typing. The correct thing to do is to write the symbols out as singular. Of course, you could pluralize the words. For compound symbols, you use a slash for division as needed. So if you were discussing the speed of a car, you could write 30 km per h. It would mean kilometers per hour, which you could write that out and that would be fine. What we see in cars, something like mph for miles per hour, is not technically correct as it would be written in a paper. Finally, the meaning of a metric symbol is different depending on if it is lowercase or capitalized. Pay attention to those M's. They can be confusing because there's capital and lowercase m's. Another thing to understand about the metric system is that volume can be described by cubed distances. So you have units of distance like centimeter or meter, but that can be used to describe the area, the volume of a cubic solid. So a cube has a volume of length times width times height. Those are all measurements of distance, but altogether they make a three-dimensional cube. We have things like cubic centimeters, cm cubed. That's equal to a milliliter, a unit of volume. What happened in the past was that scientists got together at a big convention and decided that 1 centimeter cubed of water would equal 1 milliliter of water, and the 1 milliliter of water would have a mass of 1 gram. Water's just so common, scientists thought this would be a good basis for how one thing could be equal to another. So 1 cubic centimeter of anything is equal to 1 milliliter of anything. For water, 1 cubic centimeter of water is equal to a milliliter of water, and it weighs a gram of water. For other things, they might be more or less than 1 gram in 1 milliliter because of density. For example, a milliliter of molten lead has higher density than water, so it would weigh more than 1 gram. When we convert within the metric system, it means we move the decimal around in the correct position and the correct number of places. There's mnemonic devices to help remember the basic prefixes. You don't have to have them memorized for my course, but as you practice them more often, you will have a basic understanding of some of the main ones. So King Henry drinks milk during council meetings can help us remember kilo, hecto, deca, meter, deci, centi, or milli. And then you'd realize, of course, instead of meter, it could be liter or grams because these are the base units. So here is how we converted around some units. We moved the decimal around. All of these are equivalent, but it shows from the largest units of mega down to the smallest units of micro, although there are smaller units such as pico and nano. But from here, you can see we just moved the decimal place around. What if the decimal was already moved and it's not in an easy place? That's fine. The pattern, the ability you should have is to see what unit you have, where the decimal is at, figure out what you're converting it to, and move the decimal the appropriate distance. Here, going from a small unit of micrograms up to a large unit of megagrams, we had moved the decimal in the other direction to reflect that a microgram is a very, very small amount. It's a millionth of a gram. So here's an example problem of how to convert within the metric system. 0.532 km equals how many m's? To do this, first you have to realize that kilometer is the symbol for kilometers, and M is the symbol for meters, a base unit. It's not milli, it's just M by itself. It's a base unit. Using a chart like this one, we can start in the kilo column, and we're going to count how many spaces did we move to get to the base unit, the meter column. You can see we've gone 1, 2, 3. Since we've moved 3 places to the right on that column, what we do is move the decimal 3 places to the right, which gives us 532 meters. And then we added in a 0 as a placeholder. That's the same as this 0 here is also a placeholder in a different spot. This reflects the ability to convert, since there are 1,000 meters in a kilometer. Basically, we converted it by moving around on this chart. You may know another way to do that. This is the way I do it in this course. Here's another example problem. 4,800 microliters equals how many centiliters? Realize that that's the symbol for micro, L for liters, and we're going to centiliters. Even though there's no decimal, you would assume that it's after the ones place, so you could put in a decimal if you don't see one. We start in the micro column, and we move to where we're going, which is the centi column. You'll notice here, from micro to milli crosses this line that says it's a 3 times jump. That's because milli is 1,000th of something, and micro is 1,000,000th of something. So we have to move the decimal place 3 times there. And then, when we go from milli to centi, it's just 1 place. So altogether, we've moved the decimal a total of 4 places to the left. 3 times for going from micro to milli, and once for going from milli to centi. So we move the decimal place to the left 4 places. We have 0.4800 centiliters. One more quick example. You have 42.7 liters, and we're going to centiliters. You have to realize that liters is here, and we're going to centi. So we cross here, we cross here. Crossing it, those lines, we move the decimal 2 places until we move the decimal over the 7. Now there's no 0, so we have to put 1 in, and then a 0 as a placeholder. So we have 4,270 centiliters. You'll practice more with this. One final thing. As part of our discussions of measurement, we should realize temperature is an important thing in science. There's 3 ways to measure temperature: Fahrenheit, Celsius, and Kelvin. They are all different scales. Fahrenheit is a temperature that's best suited to humans. So for humans, our body temperature is 98.7 degrees Fahrenheit. Water boils at 212 degrees Fahrenheit. As humans, a fever of 105 degrees would be very severe. And then on the Fahrenheit scale, water freezes at 32 degrees. On the other hand, Celsius is a scale based around water. Water freezes at 0. Water boils at 100. It's often used in science because water is so common, and it's a nice, neat scale from 0 to 100 that we understand. In that scale, our human body temperature is 37 degrees Celsius. And then Kelvin is a scale based around the movement of atoms. At 0 Kelvin, it's what we call absolute 0. Everything's frozen. And then we count up from there. However, in our world, it's not as convenient to start talking about water freezing at 273 degrees Kelvin. So that final little bit is about temperature. Mostly the thing you should have learned was how to convert from one metric unit to another. This has been your lab on converting from one metric unit to another. Thanks for watching. Bye.